Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. I believe you all are fine. So today I am going to discuss a multiple choice question presented in front of you on this whiteboard. As usual, I first request you, please pause the lecture, try by yourself, and whatever answer you got, please write in the comment box, because you need to accept your situation. Then only your evaluation will start, because self-evaluation is essential for improvement. Okay, and such kind of question could be useful for any exams like BSMS, B.Sc, M.Sc, any university or college related exam on chemistry, or competitive exam like CSIR-NET, IIT-JAM, etc. So the four options are given. I request you, please pause the video and try by yourself. I believe you have paused the video and tried by yourself, so it's my turn to give you answer. So first I'll explain mechanistically. At the end I shall explain within 30 seconds how can you solve this problem. Okay. So, and before going to details, I have a small request. If you haven't subscribed this channel, please do subscribe, and if possible, please support me through Patreon, because without your support, it's very difficult for me to upload such kind of videos for you on a regular basis. Okay. So let's try. Now, this is the MCQ presented in front of you. So, as usual, I suggest you students, when you are trying to solve any multiple choice question, please look at the options very much carefully, because your options and reaction condition is the answer for you. Now, see, this is actually a molecule, means if you look at, let me draw it here. This is actually dienone, and by the way, I have already described property of this dienone, which is the Dieneone-phenol rearrangement, in previous lecture. Please visit that lecture if you want to learn them properly. Fine. So this is the actual molecule. Now, in this case, this is the molecule. This molecule has a ketone, alpha beta unsaturated carbonyl. By the way, remember, alpha beta unsaturated carbonyls are good Michael acceptor. I have described this property of alpha beta unsaturated carbonyl compound and Michael addition. You may learn. Now, what is this reagent? This is actually, see, 2 into 20 mole percent bismuth chloride, better to say bismuth 3 chloride. Okay. Now question, generally this much amount of mole percent, it is not good to say catalytic, near about stoichiometry. Fine, but it's given, let's accept. And reagent is methanol acetonitrile and water mixture, simple solvent, and 87% yield. See, at room temperature, then some selective thing happen. Now if you look at this molecule, this bismuth 3 chloride is actually having a bismuth 3 plus ion. Okay, and remember, this bismuth 3 plus ion is a significantly strong Lewis acid. Generally 3 plus, if you say aluminium, gallium, those things, fine, that's a good thing, 3 plus. But this bismuth 3 plus, if you look at, this is significantly strong because of lanthanide contraction. Okay, so this inert pair effect makes this bismuth 3 plus a significantly strong Lewis acid. So if it is Lewis acid, where should it bind? The position which is actually Lewis basic in nature. Now if you look at this molecule little carefully, which centers are Lewis basic? There are two Lewis basic center. One is this oxygen, which is significantly activated by the conjugation of this carbonyl, and second is this oxygen. By the way, student, not this oxygen, because the resonance of this carboxyl group means if you take this OR, it has a resonance, means this lone pair comes here, it goes. So ultimately what it resulted, this is O minus, this is OR, having a formal positive charge. Now if you compare this, see, in this case it is neutral, in this case it is positive, in this case it is neutral negative. So effective negative charge density is more on this. So any proton addition or Lewis acid addition happens on the carbonyl oxygen. Okay. So this is an important phenomena you should remember. Now fine. So two chances, either this or this. Question why? Logically both possible, but which will give you fate? That is the question. Because remember, a chemical reaction may have infinite number of pathways, but that pathway will give you the final product, which is associated with lower energy of activation and some other thermodynamic as well as kinetic factors. Why I am saying the last word, other thermodynamic and kinetic factor, you will understand after some time. So this will give you the product. This may happen, but ultimately will not end up any significant thing. So this is bismuth 3. Now, so after addition, if you look at, first of all, this was electron deficient as an ester carbonyl, but not that much. You can say that sad, there is a cross conjugation of the lone pair on this oxygen, fine. But after this coordination, electron deficiency increases here. So the lone pair donation is more. Why? See, if just consider, it will give. Then what it will produce? It will produce this. And student, when you are dealing with big molecule, please be very, very much careful, because there is a chance of making mistake. You should not do that. Okay. So this is actually O. This is tertiary butyl. This is O minus. Now it can donate the bismuth 3 plus better way. It's a Lewis acid. Fine. Now, so, and see, oxygen is a significantly high electronegative atom. Better to say, you may consider second most electronegative atom. Why does it like to bear a positive charge? Obviously not. But resonance happens, and if there is a chance, some other way to neutralize the positive charge density on this oxygen, it will obviously do. Why I am saying this statement? What is the other way? Other way means you can consider that this bond can break and it can come here. So what is the product? You will ask, sir, why this is happening? So that why will be answered by the product. This. So this. Okay, this is O minus coordinated to bismuth 3. Now this is double bond O, and this is the 5 member. Fine. Plus what it produces? This produces a tertiary butyl cation. And it's a very, very stable. And by the way, student, I have described a dedicated lecture I made about the stability of tertiary butyl carbocation versus benzyl carbocation. You should visit that. And not only that, I have also described the stability of carbocation through hyperconjugation and resonance. Please visit if you want to learn more. I am not going to explain those in details. But in a very short word, if I say, this carbocation have 9 hyperconjugation and 3 methyl attached. So 9 hyperconjugation hydrogen and 3 plus IFF due to this carbon-carbon bond. So it will stable. Fine. So if it is stable, it will not create any problem. Now this is also stabilized. But the question is, will the reaction stop here? Obviously not. It will undergo decarboxylation. So what will happen? So in this case, it will push, it will come here. So what it produces? It produces this negative charge, this, and plus carbon dioxide. Just try to remember, sometime before I told one word, there are some other thermodynamic and kinetic factor. See, this is actually gas and it is going out of the reaction mixture, and that is a big advantage. Why? Because it is out of the system. So equilibrium will shift towards the right side. Point number 1. Second, is there any stability of carbon ion? Because carbon ions are very short-lived reactive species, and I have discussed this thing in dedicated lectures like carbon ion, carbocation radical, and carbene. So you may visit those things. So does it have any stabilization? Obviously it has. Means you can consider that it will go, it will. This is a smooth stable. That's why I am writing. Other canonical form also possible, but I am not writing this one. Why? Because this is a most stable one. Fine. And now, since water mixture is there, it is a phenol derivative, it will undergo, because medium is bismuth trichloride. Means if this bismuth trichloride gets hydrolyzed, what it will produce? It will produce bismuth oxychloride plus HCl. Means it's an acidic medium, slightly acidic. So this will not remain as O minus. So it will be converted into corresponding phenol. Fine. Now so this is the answer. Now there may be some question. The question is that why I have said 2 into 20 more percent. Why 2? I could have been directly 40 more percent. Why I haven't? Because so first 20 more percent bismuth chloride is added in the reaction mixture. After some time you need to add another 20 mole percent. Why? Because after the reaction it produces this bismuth oxychloride which is precipitated out from the reaction medium because it is insoluble. And if the bismuth 3 plus ion is not in the reaction medium, who will carry out the reaction? Not possible. That's why you need to add that additional 20 mole percent of bismuth trichloride. This is the first point. Now, and this is we understood. So, what is the answer? The answer is, sorry, from the beginning I forget to write this. So